Hey everyone, ready for another deep dive? Today we're looking at how technology is changing how we teach physics.
Sounds pretty cool.
It is. We've got this blog post from Open Educational Resources, Open Source Physics at Singapore, about a workshop they did on physics simulations.
Simulations, huh?
Yeah, specifically for teaching kinematics.
Ah, kinematics.
And they even linked to some examples on their website,
Oh,
like
nice.
one called Kinematics 1D, Freefall 01, and then one that sounds like a lot of fun called Two Cannon Aim at Each Other Projectile Motion Model.
Two cannons.
Projectile motion.
Yeah.
But we're not just talking about the physics itself.
Right.
We're going to look at how these simulations are actually changing how physics is taught.
I think that's a really interesting angle
Yeah, definitely.
because, using simulations to teach these kind of abstract physics concepts
Yeah,
could really make a difference.
for sure. It's way more hands-on and interactive than just reading a textbook.
Exactly. It's not just static information anymore.
You're actually getting to experiment and see those concepts in action.
That's got to be way more engaging for students.
Totally. But before the students can benefit,
Yeah.
the teachers need to get on board.
Oh, absolutely.
Yeah.
You can't teach with a tool you don't understand yourself.
Right. And this workshop seemed to have a really smart approach to that.
Yeah. They really wanted the teachers to get hands-on experience with the simulations.
So it wasn't just like, here's the software, good luck.
No. They actually had three main goals for the workshop.
Okay.
What were they? Well, first, they wanted to get teachers comfortable just using the simulations themselves.
So like the basics.
Yeah, how to navigate the software, what the different features do, that sort of thing.
Makes sense.
Then, they wanted to give teachers a good chunk of time to just play around with the simulations,
I like that.
to really explore and discover all the capabilities.
And figure out how they might use it in their own teaching.
Exactly. They really encouraged them to experiment and find what works best for their style.
That's really cool.
And the third goal was to give them time for feedback
Oh!
and reflection, brainstorming how to actually apply these simulations in their classrooms.
So it wasn't just about learning the tech, it was about the pedagogy too.
Exactly. They really wanted to help teachers integrate these simulations into their actual lessons.
I bet that was helpful for the teachers.
I'm sure it was.
So tell me a bit about how the workshop was structured.
Well, they started with an introduction to get everyone on the same page.
Right.
Then they jumped into a sample lesson.
The sample lesson.
Yeah, to showcase how the simulations could be used in a real teaching scenario.
Did they have a tea break?
Oh, of course. Gotta have that tea break.
You know me too well.
It's essential for any good workshop.
Right. It gives people a chance to chat and process what they've learned.
Exactly. Sometimes the best ideas come up during those informal conversations.
Couldn't agree more.
And after they'd refueled with some tea,
Yeah.
they had even more hands-on time with the simulations. Teachers could explore additional features, really get a feel for how it all worked.
It sounds like they really emphasize that hands-on exploration.
They did. And they also made sure there was time for feedback throughout.
Ah, so the teachers could share their thoughts and suggestions.
Exactly. And it wasn't just about sharing opinions. It was about using that feedback to improve things.
That's really smart.
One of the main things they focused on was revising the workshop worksheet.
Oh, the worksheet itself.
Yeah. They wanted to make sure it was as clear and helpful as possible.
Makes sense.
One piece of feedback was that it didn't provide enough information about the simulations.
Oh, so like how to actually use them with students.
Yeah, things like that.
That's a good point. If you're new to using simulations in the classroom,
Exactly.
you need that guidance.
Absolutely. And they also got suggestions to change the true-false questions.
How so?
Well, maybe make them more open-ended to encourage deeper thinking and discussion.
Instead of just memorizing facts.
Right. They wanted to encourage a more analytical approach.
Gotcha. Were there any other suggestions?
Yeah. Some teachers thought it would be helpful to include some motivating questions from existing tracker resources.
Tracker resources.
It's another educational tool.
Ah, okay.
And they also talked about ways to extend the examples for teachers working with 2D motion.
Which is more advanced, right?
Yeah, it gets into more complex physics concepts.
So they were already thinking about how to make these simulations useful for different levels of physics.
Absolutely. It was great to see that kind of forward thinking.
It sounds like they had a solid plan for putting all that feedback into action.
Yeah. Lu Kang, one of the organizers, was going to start by revising the worksheet.
Okay.
And then Dave and Gavin would do another round of fine-tuning.
So it was a collaborative effort.
Definitely. And they didn't stop there.
Oh. What else did they have planned?
Well, Dave was going to try to find some volunteers to do a demo lesson at a school.
Oh, wow. A real-world test run?
Exactly. That way they could see how the simulations worked in an actual classroom.
I bet that was valuable.
Oh, for sure. And Gavin was going to observe the demo lesson.
To see how it all played out.
Yeah, to gather data and see how the teachers and students were responding to it.
That's really cool.
They were really committed to making sure these simulations were actually being used effectively.
But I have a feeling it didn't stop there.
You'd be right.
Yeah.
After the workshop, they realized something pretty important.
What's that?
They needed more simulations.
Oh, okay.
But not just any simulations. They needed simulations specifically designed for different levels of education.
Ah, so not just for high school students.
Right. They needed simulations for secondary school students.
Okay.
And even primary school students.
Younger learners.
Exactly. A simulation that works for a high school physics class might be way too complex for someone just starting out.
Yeah, that makes sense. You need to tailor the complexity to the student's level of understanding.
Exactly. So they started brainstorming specific simulations they needed,
Okay.
like a secondary kinematics or moving car 1D model for secondary school students, and a primary kinematics or moving car 1D model for younger learners.
So they were really trying to create a whole suite of tools.
For sure. And they even mentioned one called Freefall 01 Pri, which I'm guessing is for primary school.
Prep for primary.
Yeah, most likely.
This is all really fascinating.
Isn't it?
They're really going above and beyond to make physics accessible to everyone.
I think what stands out to me most is that emphasis on tailoring the learning experience.
To the individual student.
Yeah, exactly. It's not a one-size-fits-all approach.
They're recognizing that students learn in different ways and at different paces.
And that the tools we use should reflect that.
It's about meeting students where they're at.
Exactly. And that really resonated with me.
Well, and speaking of reflecting different things,
Yeah.
I noticed that long list of popular tags on their blog post.
Oh, yeah.
And it really gives you a glimpse into the wide range of topics they're interested in.
They've got tags for everything from transfer of thermal energy in mathematics to magnetism and even quantum physics.
It's not just about physics in isolation.
Right. It really highlights how interconnected these different scientific disciplines are.
It's like they're building this whole ecosystem.
An ecosystem.
Yeah, interactive learning experiences.
I like that. An ecosystem of learning.
And all of this is happening in Singapore, which is known for being a leader in educational innovation.
That's true.
It really makes you wonder what could happen if this type of learning environment became the norm.
Now that's a question worth exploring.
What if every classroom was filled with these interactive models and visualizations?
Instead of just reading about concepts, students could actually experience them.
Imagine a history simulation where you could step back in time and witness events firsthand.
Or a literature simulation where you could walk through the world of your favorite novel.
The possibilities are endless.
And it's not just about the students, it's about the teachers too.
Oh, how so?
These simulations would give teachers incredible tools to personalize their lessons.
To meet the needs of each student.
Exactly. They could create custom learning paths for every student in their classroom.
Oh, that would be amazing.
It's a whole new way of thinking about education.
And it's not just a futuristic dream.
No, it's becoming a reality.
With all the advancements in technology and the movement towards open educational resources,
It's an exciting time to be involved in education.
I think we're really lucky to have organizations like Open Source Physics at Singapore leading the charge.
I agree. They're really pushing the boundaries of what's possible.
And making these amazing learning experiences available to everyone.
That's what's so important about their work.
It's inspiring to see.
It really is.
Well, I don't know about you, but I'm ready for a break.
Me too. There's a lot to process.
But we're not done yet. In part 2, we'll delve even deeper into the potential of these simulations and what they could mean for the future of learning.
I can't wait.
So stay tuned.
Welcome back. We were talking about open source physics at Singapore and their work with simulations.
Yeah. I was really intrigued by that long list of popular tags on their blog.
Oh yeah, what about it?
Well, you've got Workshoots and Circle right alongside quantum physics and Android-OS. It's a pretty wild mix.
It is a pretty diverse range of topics.
What do you think that tells us about their overall approach?
I think it shows a commitment to open educational resources.
Making these tools available to as many people as possible.
Exactly. But it also points to something else.
Okay, what's that?
They seem to have a deep understanding of how to integrate technology into learning.
Not just creating simulations, but a whole ecosystem of resources.
That's a great way to put it. It's not just isolated tools, it's this interconnected world of learning experiences.
And it's all happening in Singapore.
Right, a place known for being at the forefront of educational innovation.
It's pretty inspiring to see.
It does make you wonder, though, doesn't it?
About.
What if this type of learning environment became the norm?
Wow. Yeah.
Imagine a classroom where every subject came alive through interactive models and visualizations.
Instead of just reading about concepts, students could manipulate variables, experiment with different scenarios.
And actually see the results of their choices.
It would be a much more active and engaging way to learn.
And remember, we're not just talking about science here.
Right.
Imagine a history simulation where you could explore different historical periods.
Make choices that impact the course of events.
Or even step into the shoes of historical figures.
It would be a whole new way to experience the past.
What about literature? Stepping inside a novel, interacting with the characters.
Maybe even influencing the plot.
It would make those stories so much more real and immersive.
The possibilities are mind-blowing when you start thinking about it this way.
And let's not forget about the teachers.
Oh yeah, how would this impact them?
These simulations would give them powerful tools to tailor lessons to individual students' needs.
Create customized learning experiences that cater to different strengths and interests. I love that idea. Personalized learning paths within a shared classroom experience.
It's a whole new world of learning.
A classroom buzzing with students engaged in these incredible simulations.
Each one exploring at their own pace and in their own way.
And it's becoming increasingly accessible.
With advancements in technology and the growing movement towards open educational resources.
These types of simulations are no longer just a futuristic dream.
They're becoming a reality.
It's exciting to see organizations like Open Source Physics at Singapore leading the charge.
They're really pushing the boundaries of education.
Making these kinds of learning experiences available to everyone.
I agree. They're definitely an organization to watch.
I'd love to hear more about their vision for the future of education.
Me too. Maybe we can even have them on the show someday.
That would be an awesome episode.
But for now, let's take a moment to reflect on what we've learned today.
We started with a single workshop focused on physics simulations.
And now we're talking about the potential for those simulations to revolutionize learning across disciplines.
And that's what I love about these deep dives.
You start with a specific topic and end up uncovering all these fascinating connections and implications.
It really gets you thinking about the possibilities.
It does. Speaking of connections, I think it's worth revisiting that list of tags from the blog post.
Oh yeah, what else caught your eye?
I noticed kinetic model and waves in there.
Those are pretty fundamental concepts in physics.
They are.
And then there were tags like mathematics and measurement.
It really reinforces this idea that physics isn't an isolated subject.
It's interwoven with other disciplines.
And understanding those connections is crucial.
It's an ecosystem. This time, an ecosystem of knowledge.
Where everything is interconnected.
And these simulations offer a tangible, interactive way to explore those connections.
It's not just about memorizing facts and formulas.
It's about developing a deeper understanding of how things work.
How they relate to each other, how they impact our lives.
It's about fostering a sense of wonder and curiosity about the world.
And that brings us to our final takeaway for today.
We've seen how technology is changing the face of education.
But technology is just a tool.
It's the human element.
The curiosity, the creativity, the passion for learning.
That truly drives innovation and progress.
It's those human qualities that will shape the future of education.
And that future is looking bright.
I agree.
Thanks for joining us on this deep dive into the world of physics simulations and their potential to revolutionize learning. So we've been talking about how simulations are changing things for physics education.
Yeah, and even hinting at how they could be applied to other subjects, too.
But before we go too far, let's circle back to that blog post for a sec.
Okay.
I know we've talked about those popular tags they have.
Right.
But I feel like there's more to say about them.
Yeah, I think so, too.
What else stood out to you?
Well, the tags modeling and problem solving really caught my eye.
Interesting.
Because it shows that they see simulations as more than just flashy visuals.
Yeah.
They're tools for developing critical thinking skills.
So it's not just about passively watching something happen on a screen.
No, it's about actively engaging with the material.
And figuring things out.
Right. By manipulating variables and seeing the outcomes, students can really grasp cause and effect.
Like little scientists testing hypotheses.
Exactly. They're experimenting and refining their understanding through trial and error.
It's learning by doing.
And it's super effective.
Plus, it goes back to that idea of tailoring the learning experience to the student.
Oh, definitely. Allowing them to learn at their own pace in a way that makes sense to them.
And when you combine that with teachers sharing ideas and best practices.
Yeah, like in those workshops.
it creates this amazing environment for innovation in education.
It's really cool to see.
You know, I'm starting to see a pattern here.
What's that?
It's not just about the technology itself,
Right.
it's about a change in how we think about learning.
Moving away from rote memorization and towards a more active, inquiry-based approach.
Exactly. And that's something that can apply to any subject, not just physics.
Oh, for sure. Imagine history students using simulations to explore different historical scenarios.
Or literature students creating interactive narratives.
It could completely transform the classroom.
What if the walls of the classroom could disappear
Whoa, yeah.
and students could dive into any topic that interests them?
In a totally immersive way.
It's an incredible vision.
And it might not be as far off as we think.
True, with technology advancing so rapidly.
The possibilities are pretty much endless.
And organizations like Open Source Physics at Singapore are leading the way.
Absolutely. They're not just creating simulations.
They're creating a whole new way of learning.
A blueprint for the future of education.
And that's what makes their work so exciting.
It really does give us a lot to think about.
Like, what role can we play in shaping this future?
How can we support the development and adoption of these new learning tools?
And most importantly, how can we ensure that they're used to help all students develop a love of learning?
Those are big questions.
But they're worth asking.
Definitely. And who knows, maybe some of our listeners will be inspired to create the next generation of interactive learning experiences.
Maybe they'll be the ones to shape the future of education.
That's an exciting possibility.
Well said. Thanks for joining us for this deep dive into physics simulations and their potential to revolutionize education.
It's been a fascinating conversation.
It has, and I have a feeling this is just the beginning of a much bigger conversation about the future of learning.
I think so too.
Thanks for listening, everyone.